One of the things that I wanted to ask you about was your work on the nature of time, because for a while you've been challenging conventional ideas about time. What does mainstream physics get wrong about time, do you think?
Yeah, it's physics, and maybe even more than physics, but physics is the main culprit. I completely agree with you there. We do not perceive the passing of time as worthy of having a main stage role, central stage role in our science. What do I mean by this? This activity of the clicking of time, ticking forward, is not an element in foundational physics, theoretical physics, that comes understandingly because a lot of physicists we wish the understanding of the world to be based on symmetries, so very beautifully orchestrated equations that evolve forwards in time, backwards in time, and conserving quantities. So the ticking of time, passing forward, and time always moves in one direction and not back, is the very fundamental, almost like the first principle that we can see in nature around us. And yet it's incredibly difficult to put that in our theories of the world in physics, because we write equations that also admit the solution that evolves backwards in time. And then it's incredibly difficult to explain why we don't see that in nature. And so then scientists have to say that we observe the systems that evolve time increasing because the initial conditions of the system were very carefully selected. So by saying the ball walks down the hill, not up, because I placed it up the hill, and so it's rolling down the hill, rolling down the mountain. And that's a very good explanation. The thing is, if you are a cosmologist, we pass backwards the burden of explanation back and back in time. You evolve backwards and backwards, and we arrive at the Big Bang. And there's a huge burden of proof to pay there, that we don't know how to answer the problem of all of these initial conditions that have to be explained at the birth of the universe, at the Big Bang.
If I've understood that correctly, we feel like personally that time is fundamental, it's moving forward. There isn't anything much more fundamental about our lives than that time is moving forward.
Exactly.
But if you look at the equations of physics, they can go either way. So where does time come from? And it's not an illusion, but it's not fundamental. It's just an artifact of the way that the universe was set up initially.
Yes, yeah, exactly. Yeah, exactly.
So this is the argument with entropy, where if the universe was very ordered to begin with, and it's gradually getting more disordered, that gives us the arrow of time. Yeah. Are you not convinced by that? You think that time is more fundamental than that?
Time, yeah. So time, I believe, is the first principle about nature. If we want to understand how reality comes to be, I believe the passing of time is the first principle that needs to be included there. Because we do not account for this mystery of the passing of time ticking forward each moment, we end up with equations that are too perfect for a world that we might not understand so perfectly, in the sense of our equations are almost too beautiful. This comes from the Greeks. Physicists are, I'd like to say, to tease my colleagues sometimes, we are closet mathematicians, meaning that we all love math. We actually wanted to be a mathematician, but it's really cool to be a physicist also and study the universe. And so we become physicists, but we maintain this passion for the symmetries and beauty of mathematics. And in Greek, the Plato and the Platonic view of the world, the skies were always perfect, and the comets and planets evolved in our skies following beautiful, perfect crystalline equations. And that's the world of mathematics. And in those ancient times, they understood the earth was very messy. There was no equations to rule our daily messy world. But out there was this beautiful, perfect world where a thinker could escape to and understand the world of the stars, that was just very symmetric, crystalline. So we carry in our community, more the theoretical community, we carry a lot of this desire for understanding the world as this perfect symmetry structure that is so clean that it has no imperfections. But sometimes the imperfections are the beautiful part.
Yeah, so we start with this messy, imperfect world and then derive these equations that look so beautiful and perfect, and then start to think that the equations are more true than the world.
Exactly.
And therefore, if there's no time in the equations, that means there can't be any time in the world, forgetting that actually the world was the thing that was real.
Yeah, exactly. Right. That's so important. That's so important. We don't mandate how the world works just because we're scientists. It's the world that says to us, reality is showing us how she works. We don't, because we're scientists, we don't go and tell reality how to behave. It's the other way around.
So how do you go about putting time back into the physical understanding of the universe? What happens to the equations when you acknowledge the existence of time?
So we developed a model, a proposal for a quantum gravity model that incorporates irreversibility. So the passage of time, irreversible evolution is something that I believe should be weaved onto the foundations of physical theory. And the equations are irreversible in themselves. So meaning that if you know the state of the system today, you cannot retrieve the past state of the system, the previous state of the system, where it was a few moments ago. And the system only evolves in one way, in the regime of quantum gravity. We start with time and the passing of time, and then we observed the emergence of space. Then we have to build the standard mainstream physics out from these irreversible time evolution. And that's essentially what we observed. Made a computer with simulations of this irreversible passage of time, and we could retrieve the regime where physics is time symmetric, which is the normal classical evolution.
So you have irreversible events that are happening, and the laws are emerging and evolving as you go, rather than sort of existing with in a certain way beforehand.
Exactly.